Hello, everybody. My name is Alex Teal. I'm a co-founder and CTO at Aotu.ai. And today I'm going to talk to you a little bit about OpenVisionCapsules and how it can be used to deploy OpenVINO models easier and make video analytics more accessible to developers of deep learning models. And so the first thing we're going to talk about today is we're going to go over the usual technical debt that will grow over time in any kind of video analytics product. And so there's sort of three stages of technical debt. The first is there's the building of the video inference pipeline. And so this will seem simple at first, but gets more complicated over time. The second is the requirements of inference. Those will change as your product grows and will get more complicated over time. And then the third is actually making a deployment be very stable and scalable and potentially clustering across many different instances. That also starts out simple but becomes more complicated over time. And then we're going to talk about how OpenVisionCapsules helps solve these problems and how OpenVisionCapsules helps solve the direct customer engagement problem, which is allowing algorithm developers talk most directly with the customers that will be using those results from those algorithms. And then I'm going to show you a deployment platform called BrainFrame, which is compatible with OpenVisionCapsules format. And so first, let's talk about video inference pipelines. So in any kind of video analytics project, usually the first thing you do is you connect to a camera and you load your model and you run some inference. And so here on the left, you can see kind of what that looks like, right? You might use GStreamer backend or FFmpeg backend to connect to your IP camera or your webcam. And then you'd get those frames and you would do some pre-processing, maybe cropping the image, converting to black and white, subtracting the mean. There might be some operations to do there, and then you run it through the model. And so this shows how to run inference on one model with one camera. Very simple. But then things get much more complicated once you start trying to account for all the possible things that can go wrong in production, right? This code I showed you, it doesn't seem to check to see if the camera actually connected. There's no retry mechanisms there for when the camera goes down and eventually comes back up. The image preprocessing and inference code is all in parallel with the same thread as the camera, so that's something that would slow down performance. And furthermore, we're not doing anything with that inference code, right? Where's that inference information going? We need to serve that somehow, perhaps split this all into different microservices. And so once you account for that, things get a little bit more complicated, right? And then what about supporting proprietary cameras? All these things sort of add up and become more complicated. And so in our experience, this adds up to 15,000 lines of code for the streaming and serving of this kind of data. And so then what about technical debt for inferencing? So in that last example, I showed you one model. So what does it look like if you read from a frame over here and then you run inference on multiple models? So in this example here, this is code from a text detector. And so here we run inference and we find the locations of the text, for example. But you might run inference and find locations of people or faces. And then you'll want to run inference on those face crops. So maybe you do face recognition or text recognition. And so you'd have to run inference for every detection in that first model on the second model. And then you might want to do something on the outputs of those outputs, right? And so in this code, it's all very simple, maybe 200 lines of code once you actually fill out the comments there. But there's no asynchronicity, right? You're not doing anything in parallel. You're not handling any of the errors that could happen to these possible models, right? And what about the model loading and unloading? And what if you want to load one model onto the GPU and the other model onto the a Myriad X on your computer? And so once you start adding those types of features, you get a lot more complexity, right? And so OpenVisionCapsules is going to help with that kind of thing, right? So OpenVisionCapsules helps with the first two problems that I've shown so far. And it'll help you write easily batched code, right? So where many images from different video streams are fed into the model at the same time, which helps reduce memory overhead, and it helps in a lot of cases with GPU architectures run things much faster. And it also helps connect different inputs and outputs of models so that the programmer doesn't have to think about how to coordinate that code. And then finally, what about these stable deployments everyone's always talking about? Right? There's a whole lot of sets of microservices that go into making a deployment be stable. And so stability means not just that it runs for a long time, but that the customers are going to have a good experience. When they connect their camera, they expect it to work, right? When they get data from these models, they want to visualize it, right? So you're going to need some kind of dashboard there. When they want to integrate with their existing technologies, they're going to need a good API. And all of that means lots of documentation, containerizing everything so that it always works, databases, all kinds of things. And so these are all things that everybody who works in video analytics will have to build at some point to deploy their product. And so at Aotu.ai, we work on a product called BrainFrame, which is compatible with VisionCapsules, which helps deploy algorithms and do all of this for you so that you can get something to production quickly. And so what are these capsules, right? What is OpenVisionCapsules? So capsules are a format for wrapping your deep learning model into a way that it can be connected with other models. Inputs can go into another model, like a face detector might feed into a face recognizer, which might feed into, a face aligner. And it lets algorithm designers focus on what they're building, the problem they're trying to solve, and not on retry logic for a video pipeline for IP cameras or saving that results to the database. All of that will be taken care of by the platform that deploys the vision capsule. And so what we want to accomplish here is we want people to think of problems in these three steps, where they find a problem, whether it's queue management in a store to find out how long customers are waiting, or making sure that people are wearing their construction safety hats when they're inside of dangerous zones, or making sure that in a restaurant that workers who have touched raw chicken wash their hands before they go to a sanitary area of the kitchen, or all kinds of industrial use cases or behavior, right? We want them to find a problem, and then all they have to do, these end users, all they have to do is pick their capsules, drop them into the platform, and load their video files and solve their problem immediately. We just don't want people to have to write code to coordinate algorithms, because that will leave a lot of customers wondering what could have been. Maybe they could have extracted a little bit more from that video and solved their problem even better. And so I'm going to show you a demo of BrainFrame, which is compatible with the OpenVisionCapsules format. And we'll show you kind of the workflow we hope to accomplish. And so what I have here in front of you is the BrainFrame client. So BrainFrame is a server client architecture, and the server consists of many different containerized Docker programs. And what I'm going to show you is just a day-to-day usage of BrainFrame and how these vision capsules help solve problems. So the first thing I'm going to do is I'm going to add a video source. And so BrainFrame takes IP cameras, webcams, video files. So I'm going to add a webcam, and so you can name it. So Alex's room. And so we'll add that. And so then what you'll end up seeing is you'll see me, and you won't see anything happening. You won't see any algorithm results. You don't see this cat, for example, being read. You can go to the install directory of BrainFrame and go to Aotu.ai/doc/downloads or any other hub for capsules, and you can look at capsules. So you can actually, download our age classifier or behavior classifier, or if you want to know if someone's wearing glasses, what their gender is, their hats, vehicle colors, right? face detection, recognition, people, license plate reading, text reading, facial landmarks, all kinds of things. And so you can just go in and you can click these and download them. And so I've already downloaded several capsules. And so let's try one in. And so what I'm going to do here is I'm just going to click and drag this in from the downloaded capsules. And you'll see almost immediately that there's person detections happening here. And so that's the kind of beauty of the capsule system, is you just have immediate results. You can see these algorithms running live, and you can see how they're performing. We can even go into the settings here and try to see like extra data here, so we can see the detection confidence for these bounding boxes. And so now what else can we do, right? So we can start dragging in some more capsules. So for example, let's drag in a face detector here. And so now we're detecting both people and faces. But what about something that requires a face detection as input? So we have a face landmark capsule here, and it actually doesn't operate on the whole frame. It requires the location of an existing face to operate. And so I'm just going to drag that in there, and you'll see pop up here now like the person, the face, and then the landmarks within the face. And so that means that BrainFrame is running this capsule, finding faces, and then running these in parallel, feeding inputs from this capsule into that one. And so that's really cool, and really showcases how powerful the system can be. And so unloading these capsules is as easy as just selecting them and dragging them, or yeah, in this case, just deleting them. And so you can see now it's just the person detection. And so you can also go into the UI and view the loaded capsules. You can disable them programmatically through the REST API, re-enable them. You can play with thresholds. So for example, if we had a really low threshold here, we'd be detecting quite a few people. If we leave it at 0.5, there we go, we get just one person detection. And so now what we can do is we can start stacking these capsules to solve problems and use that information. So for example, let's load a video file here that has a lot of vehicles traveling in it. And so this person and vehicle detector is already finding these vehicle detections. But one thing you'll notice is that we don't actually know in between any two frames that this is the same vehicle as before, right? Let me actually disable all this information. It's hard to see. So we can actually track the location of bounding boxes over time if you add a capsule that can track vehicles. And so you'll see pretty immediately all these lines start appearing, which means that BrainFrame now understands where these vehicles have been and where they're going to. And so this means that the outputs from these bounding boxes from this capsule are feeding into the inputs of this vehicle tracker, which is adding tracking information. And so you can see on our downloads page the required input and output for every capsule. And so some of these don't require any inputs, but some of them require inputs, right? And so you can pick and choose the capsules based on that. But BrainFrame will handle the deployment of the capsules and making sure that everything is stable and works correctly. And so once you have these lines and tracking and all of that happening, you can start getting more information. So for example, let's say we want to track these slow lanes and find out how many people are crossing there at any given time, and then the fast lanes, and find out, how many, are there buses in the fast lanes, for example? Maybe there's a rule in the city against buses being in these lanes. And so now we're counting these vehicles and we're keeping track of how many vehicles cross, in which direction, and more. And then it's as simple as going to your localhost here, where BrainFrame is hosting a dashboard. And so we can actually track for each stream the uptime, any alarms that might be going off, which I haven't set any alarms, and the amount of traffic. And we can also go in here and see the traffic for vehicles, for example. So this stream doesn't have any vehicles. Maybe there's a false detection there, but this one has already seen 800 unique frames of vehicles. And we can also see this line here as we zoom in as the number of vehicles increases that crosses it. And so the idea here is customers should be able to choose their capsules based on what they want to solve, deploy them on a platform like BrainFrame, which will handle all of the video and extraction, and then have a good experience with good documentation and a good usable REST API as well. And so BrainFrame has all of that and makes it easy to deploy all of these things. And hopefully people will be able to more easily solve problems in the video analytics space. And so I hope this was a helpful presentation for everybody. We are always available on forum.aotu.ai if you have any questions about deep learning or deploying algorithms to the cloud or edge AI. So of course, please contact us. Thank you so much for listening.